Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians. Welcome to the podcast where math is figureoutable. I'm Pam.
And I'm Kim.
And you're Kim. You found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about making sense of problems. Oh my goodness. Noticing patterns and reasoning using mathematical relationships. We can mentor students to think and reason like mathematicians. Not only are algorithms not particularly helpful or fun in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be. Why are you laughing at me?
I don't know. I don't know what's wrong with me. We've spent a lot of time together recently.
Yeah, that's true. It's been a week. Okay, so Kim, in today's episode, we thought we realized that we could maybe have had a well, let me tell you what happened. I was in a Twitter conversation, which was super cool. It was fantastic. Somebody asked, I should have probably looked up who started it. Somebody asked Tad Watanabe and me about some standards for fractions. And they asked Tad about standards in Japan and me about standards in the US. And Tad is quick on the draw because before I could answer, he had answered for both of us, which thanks, by the way, because I didn't want to look it up. I mean, I kind of knew, but I would have checked. So thanks for that, Tad. Appreciate that. And then proceeded to have a conversation back and forth about maybe something was missing. There's lots of things we could talk about today. But part of the conversation, I think specifically Dr. Lori Jacques was involved and Professor Smudge was involved, neither of whom I have met in person, although I would love to, because they have very respectful and intelligent, thoughtful conversations on Twitter. I'm thoroughly enjoying the conversations that we're having. But along the way, there was some conversations. So it was about fraction standards, right? There was some conversations about fraction division. And there was a conversation about unit fractions divided by a whole number. And as we went back and forth, someone said something about, well, but like 1/25 divided by 4, like that we can't expect students to reason through that. And I was like, yeah, we need to. Like, we need students to reason through something like 1/25 divided by 4. Because to me, that's like the definition of what fractions are. Like, when you divide fractions, then you have to think about the relationship to the whole and how that. Anyway, back and forth, we kind of went. And somebody in the conversation said, I don't think a typical primary pupil would intuitively know this. Okay, real quick. Can you tell they're British? Pretty sure most of the people in that conversation were British. Not Tad. He's from Japan. Now lives in the States. But I don't think a typical primary pupil would intuitively know this. And Kim and I had a conversation about that.
Yeah. I remember seeing it on Twitter, actually. And, I'm not a super Twitter engager, but I was struck by the idea that kids couldn't, I'm air quoting, intuit this. And I kind of wanted to chime in, but, I don't really as much. But I wanted to say, what is that?
You would have if it was on Facebook, huh? You're more of a
probably.
Are you
probably,
more Facebook or Insta? Which one? Facebook, Instagram?
Facebook, probably more.
Okay.
I just have all the words, and I struggle with the character count. I just really do. I struggle.
That's awesome. So I'll hang on Twitter, you hang on Facebook. We make a whole person that way too. Yeah.
Well, so I was struck by the idea that there's a thinking that kids can't intuit things. And so I wanted to say, like, what does that mean? And you and I agree that we need to give kids experiences so that they can.
Yeah. And so like maybe I don't think a typical primary pupil would intuitively know this means that I don't think they would know it without experiences first.
Yeah. Yeah.
But we absolutely think kids can use intuition and the budding understanding they're gaining about fraction
Yep.
to reason through what is 1/25th divided by 4. I think they could reason through that. And we got really kind of interested in that. But part of what
Yep.
we realized was in our series, episode 142, 143, and 144, all about fraction division, that
Yep.
we probably should have had a precursor, like,
Yep.
I don't know, 141 and a half or something, should have been the episode we're going to do today. So this
Yep.
is kind of a precursor conversation that has everything to do with building the idea of what a fraction is. Like, how do you
Yep.
name a fraction, and how do you make sense of naming that fraction? So we thought, what do I do when I want to help like develop an idea? I write a problem string. It's
Yep.
like
Yep.
my go-to. I write a problem string so I understand it better, and then I think that through experiencing that problem string, I hope that whoever's experiencing it can also learn to think that way, like use those relationships to solve problems in that manner. So, y'all, you're going to need a pencil for this one. If you are driving in the car, all the best with this. Maybe pause and come back to this one, or feel free to listen to it knowing you're going to want to re-listen to this one with a pencil. At least, maybe not everybody, but
I'm going to point out that you said pencil because that is the
oh
gosh.
gosh, what in the world?
That's the correct.
I have no idea why I said
cool.
pencil today, because I actually have a pen in my hand.
Okay.
I don't even know if I have a pencil in my desk. Okay, I'm looking. I do have a pencil.
Grab it.
Hey, and it's a Ticonderoga because you convinced me that was the best. I do have a mechanical pencil too, but I think it's broken. Yeah, see, that's how often I use that one. All right, so I have a pen in my whatever. Pick something up to write with. That's funny. I must have been because I was talking to you, maybe. Who knows? Okay, so all right, here we go. Kim, I know you're not a big candy bar fan, but we're going to use candy bars anyway. Yeah,
Okay.
y'all, if we go to the snack aisle, I'm getting a candy bar, and Kim's, what are you getting? A gummy something? Gummy? Salty?
Like sour. Well, yeah, if I have a choice of no candy, it's chips and salsa every time. But if I have to go candy, then it's going to be a like
Someone
chewy
forces
sour.
you to go candy?
Chewy sour, yeah.
Yuck. No. Chewy sour. Like, I don't think you could pay me to go chew. Anyway, so think candy bar if you would.
Get it.
Okay, so there's only a half of the candy bar left. You and I are somewhere. There's only a half. You wouldn't eat it. It can't be you and me. My daughter and I. That would work. My daughter and I are hanging around. There's only half a candy bar left for whatever reason, and so she and I are going to split that half a candy bar. So what is 1/2 of a candy bar divided by 2? In other words, I'm going to say that again. Half of a candy bar shared among 2 people. And I've written on my paper 1/2, the division symbol that looks like a subtraction sign with the 2 dots, divided by 2 people. So 1/2 divided by 2 people. How much candy bar would each of us get?
You would each get 1/4 of that candy bar.
How do you know?
Half cut in 2 pieces is a 1/4.
Okay. Yeah, it's almost hard to say because it's
yeah.
So if I drew kind of a whole candy bar, and then I took half of it and it went away, it's gone. And I said, so you only have this half left, and we cut it into 2. How many pieces would have been in that whole candy bar?
Yeah,
if I'd cut. Yep. There would have been 4 if I'd cut both halves into 2. And I kind of, on my paper, I've got this whole candy bar, and I'd split it in half, and I kind of scratched out half of it, but it's kind of still there, like kind of a ghost image. And so you only have this half image that's sort of solidly there left. We cut it in half. Well, if I'd cut the whole candy bar like that, you'd have 4 total pieces, but I only get 1, Abby only gets 1, and so we get 1 of those 4 total pieces, 1/4. Is that a way to think about that?
Yep.
Okay, next problem. Tomorrow we're eating a different candy bar, and there's only 1/3 of it left. Man, who keeps eating all the candy bars? So there's only 1/3 of the candy bar left, and Abby and I are going to split it. So I've got 1/3 divided by 2 people. 1/3 of a candy bar divided by 2 people. how much would each of us get?
You would each get a sixth.
Why?
And this time, because you talked about it, I sketched a candy bar, and
Okay.
I split it into thirds, and I focused just on one of the thirds, and I cut
Okay.
that third in half. And so those pieces would be a sixth, because you would need six to make the whole candy bar in that size piece.
In that size piece. Nice. Nice.
Yeah.
Cool. So you'd have six. So 6 pieces and you one of those. So your final answer is 1/6.
Uh-huh.
One of those 6 equal size pieces. Cool. Nice. All right. How about 1/2 of a candy bar? It's a different candy bar now. Or maybe we're back to the first candy bar. A half of a candy bar. We got half of a candy bar, but 2 of my sons came along because they also like candy bars. 2 of my sons came along, and so now there's 4 of us that are going to share that half a candy bar. So we got half a candy bar, but there's 4 of us. So 1/2 divided by 4. What's 1/2 divided by 4?
Not very much candy bar. It's gonna be an eighth of a candy bar.
How do you know?
So I actually thought about the first problem, and when you had a half divided by 2, that was a fourth.
Mm-hmm.
But I know that divided by 4 is kind of like divided by 2 and then divided by 2 again.
Oh.
So that would be an eighth. And because
You kind of thought about,
you need 8 of those size pieces to fill the whole candy bar.
yeah, and so am I right? You kind of thought about that fourth. If it was half of a candy bar shared by 2 people, everybody got a fourth.
Mm-hmm.
And you said, what's half of that fourth?
Yep.
Yeah. How do you know what half of a fourth is? How do you know half of a fourth is an eighth?
Because you would need twice as many. So it's half as big, and you would need twice as many to fill the candy bar.
Nice. I will never forget the day when I came home one day and I said to my son Cameron, who is the inspiration for all of this, and I'm always asking him how he's thinking about stuff. And I came home one day and I said, "Hey, dude, how do you think about equivalent fractions?" Because at that point in my mathematical career, I only knew equivalent fractions as this formula where you wrote down this sort of common denominator thing, and it was this goes into that times that, and then you could write an equivalent fraction. It was totally steps that I did to find equivalent fractions. And I said, "What do you know about equivalent fractions?" And he goes, if you cut the pieces in half, then you have to have twice as many. I will never forget that day. I had to totally think about what he said, but it's exactly what you just said. Like, how do you know that a half of a fourth is an eighth? Well, if you cut those fourths in half, then you have to have twice as many to fill the whole thing. So you'd have 8 pieces, right? If you had 4 pieces. So if you had 4 pieces, then I've got 1/4, you've got 1/4, fourth, and a fourth. But if you cut those in half, each of those in half, you've got 8 total pieces. You'd have to have twice as many to have the same whole candy bar, right?
Mm-hmm. Mm-hmm.
Did I hopefully say that
Mm-hmm.
right.
Yep.
I can't hear you. I need to turn my mic up.
Am I
Are
not
you
talking
there?
loud enough?
Hello. I don't know.
Sorry.
Okay, cool. Next problem. How about, what if I had a fifth of a candy bar? Let's say it was a really big candy bar. I had a fifth of a candy bar, and 4 of us want to share that fifth. So it's a giant size candy bar. We've only got a fifth, but it's big. But 4 of us are going to share it. Now what kind of piece do we get?
You get a 20th.
And how do you know?
So if you cut a candy bar into fifths,
mm-hmm.
and you divide one of those fifths into 4 pieces, then you would need 4 and 4 and 4 and 4 and 4. So 20 pieces to fill the whole candy bar. Each of those fifths would have 4 pieces.
Each of those fifths had 4 pieces. And so if each fifth has 4 pieces, it's almost like you then have to take those 4 pieces times those 5 fifths, 5 1/5ths.
Each of those 5 pieces times. Wait,
each of those 5 1/5ths has 4 pieces in them.
Yes.
Each of those 5 1/5ths has 4 pieces. So you'd have 20 total of those pieces. Therefore they are a 20th. Cool.
Uh-huh.
And the last problem. What if I had 1/25th of a really, really large candy bar?
Okay.
I've got this super, picture this long candy bar that goes across my whole kitchen.
Okay.
And Maybe we could say it was like, have you ever seen those gutter Sundays? We did this once at a family reunion. It's like you take a rain gutter that's really clean. Oh, it didn't feel like it. Anyway, it was a really clean rain gutter, and then we put ice cream in it and all the toppings
Oh,
and stuff. And then we all ate. You've never seen that? It's like a Guinness
I
Book of World Records thing.
I feel like
I
I've
have a
seen it, but
delightful sister-in-law that, yeah, she thought it would be fun, and it was oddly fun. But anyway, so picture this really super long thing, right? Super long thing.
mm-hmm,
Can you
mm-hmm.
picture 1/25th of that really really long candy bar?
Yep,
1/25th.
yep.
Tell me about that 1/25th. What is it? What does it look like compared to that whole candy bar?
It's a section that you can repeat, and there'll be 25 of those sections to fill the whole thing.
Yeah,
It's
so
like
I'd get one, you'd get one.
yep.
25 people would get an equal, a fair share. Cool.
It's like a whole
So if I'm
class
looking
worth.
at just that, hey, so that'd be a great way of thinking about it. Like if I had a class of 25 kids, whatever the piece would be that each kid would get, that would be 1/25th. They're
Yep.
even equally shared pieces. Cool.
Yep.
Okay, now take that 1/25th that one kid got, and I'm kind of picturing that 1/25th actually the size of my clipboard right here. Like it's a
Okay.
really long candy bar, and so by that,
Yep.
when I got my chunk, my 1/25th, it's the size of my clipboard. Here it sits. And darn it, all three of my friends didn't come up, and so I'm nice. I'm gonna share it with them. It's the size of my clipboard. That's a pretty big size thing, right?
Yep.
And so that 1/25th is going to be shared with four people. 1/25th divided by four.
Yeah.
How much of the whole candy bar did each of the four of us get if we took that 1/25th and divided it into four equal shares?
You'd each get 1/100th
Of
of the whole
the
rain
whole candy
gutter
bar.
candy bar or whatever.
Whatever we're sharing. Yeah.
Yeah.
1/25th of that whole thing. So it's almost, well, do you want to keep talking or do you want me to kind of,
Well, when you were talking, I was just actually thinking about how if you're sharing, if you're dividing each of those 1/25ths into four parts, I was also, because we were talking about a class, I was also picturing like you can feed now four times as many people. So it would
oh,
be like you'd get 100th because there could be 100 people that can have their portion.
it's almost like you said, hey, everybody in the class, you each got 1/25th of this very large candy bar, but
Yep.
there's four classes total,
Yep.
our class
Yep.
and three other classes. Hey, everybody go share your clipboard size piece with
Yep.
somebody in each of the other three classes.
Yep.
And like if we did, hey, we could feed all four classes with 100 pieces,
Yep.
100 equal size pieces.
Yep.
Cool. So it's almost like you sort of took that 25 and kind of scaled it by four a little bit.
Mm-hmm.
Like when you said 1/2 divided by four, there was kind of this thought about like this 2 times 4, and the answer became 1/8.
Mm-hmm.
And when it was 1/5 divided by four, there's this 5 times 4, and the answer became 1/20th.
Mm-hmm.
And when it was 1/25th divided by four, there's this relationship of 25 times 4, and the answer became 1/100th. It
Yeah.
seems like there's some kind of scaling going on here.
Mm-hmm. Mm-hmm.
It's almost like when you cut the pieces into more, when you cut the section, the fraction into more pieces, it's almost like you can then scale how many more kids can eat.
Yeah.
And if more kids are eating from the same thing, their piece got that much smaller by that same scale factor.
Yep. Yep.
That
Yep.
was
Yep.
really general how I just said that.
Well, and I was looking back at the previous problem because I happened to write them down. So when you got a fifth divided by four, you got
Mm-hmm.
1/20th.
Mm-hmm.
But see if I can say this, when you got a fifth of the size of the piece, so going from 1/5 to 1/25th,
Mm-hmm.
then your portion went from 1/20th to 1/100th. Your portion got
And
also a
yeah,
fifth smaller.
sorry, I shouldn't have interrupted you. Yeah, because I kind of got
No.
excited. If you've done as we asked and get a pen and pencil and write these down, then you might also have had on your paper 1/5 divided by 4 equals 1/20th, and below
Yep.
that 1/25th divided by 4 equals 1/100th, and then you could sort of see, ooh, when that fifth got cut into 5 chunks to make
Uh-huh.
1/25th,
Uh-huh.
then the 1/20th was also cut into 5 chunks to make 1/100th. So we can not only sort of scale inside the problem, but we can scale between the problems. Nice relationship. So I don't think at that point we're done with, well, let me say one more thing about that problem string. Y'all, I think that problem string is the definition of fraction. Like it is, if I have a fraction, like a 1/3, and I cut it in half, then I've got to think about how do I name that new piece I've come up with? And I do have to reason about, well, if I've cut a third in half, then how many pieces are in the whole? If I cut all the thirds in half, how many total because I'm trying to name what that piece is. But that is the understanding of what a fraction is, that we name a fraction, we name that piece by its relationship to the whole.
Yeah.
And as long as we've shared fairly what is the relationship of that piece to the whole is the understanding that we need kids to have. Kids need to understand that is the definition of fraction. Yeah.
And I think we can have these experiences earlier than a traditional fraction division
Oh, I'm so
standard
glad you
might
brought that up.
call.
Yeah, because that was the original part of the conversation, right? Was where does this standard, a fraction divided by a whole number, come into the standard somewhere? And fifth grade is way too late for these more simple questions to come up. Now, probably the 1/25th divided by 4, I'm not having that conversation in third grade,
Right.
but I am having the conversation about 1/2 divided by 2 and 1/3 divided by 2. And even 1/2 divided by 4, and I think 1/5 divided by 4. I'm absolutely having those conversations in third grade because I want to get at what fractions actually mean. Yeah, I think it's super important.
But I think it's far less about, let me show you how to record this notation and what to do, and more like you get kids involved in a thing that has them do this dividing, and then you tag notation afterwards. Like they're doing some work about actually dividing things. And we just, what could that be called?
Hey, when you say that, do you mean, I'm asking because this came up in the Twitter conversation, do you mean that you're going to give kids a bunch of cubes and or candy bars and knives or scissors? When you say and actually do the dividing,
I don't think it has to be an actual object, but I think if you give them a context where they can make sense of sharing items, sharing things, then we use models that represent their thinking. I mean, we were in a third grade class a couple years ago where kids were really grappling with naming the things and like renaming the things. And I don't think they needed an actual brownie in front of them, as long as the representation they could make sense of.
I think we should do a whole episode on that some other time. I'll just drop in. We don't really like, and research supports this, that circles are not fantastic to have kids start to divide themselves, because circles are super hard to divide evenly. So one of the reasons we use candy bars is because a rectangle is much more easy for kids to get some sense of dividing.
Yeah.
We do like kids to do things like divide like a strip of paper by folding it and making sense of kind of how they're thinking about. So we do want kids to have some experiences actually dividing things and creating fractional pieces. But I don't know that we would suggest that in this case, trying to think about 1/25th divided by 4, I don't think we would give them 100 cubes.
No.
And create 1/25ths as 4 cubes each. It's almost like we've done the work for them in order to hand them the 100 cubes and divide it into 25 sections of 4 cubes each. And then say, okay, here's your 1/25th divided by 4. Then they're looking at that reunitizing that's happening. You've done the work for them. So I don't think we would recommend using like objects in that way.
Yeah.
Okay, cool. I'm looking at the time and I'm aware. Kim, do you think we can do this next string in an episode? I'm wondering if the listeners are like, do it. I think we can. Let's dive in.
Let's do it.
Maybe
Let's do
it. I won't spend as much time explaining.
Okay.
All right, here we go.
Okay.
Because I kind of did a lot on that last one. All right, here's your first problem of the next string. 12 25ths divided by 4.
Oh, okay. Non-unit fraction. 12 25ths is divided by 4 is 3/25.
Okay. And did you just
I
do
don't
some keep, change,
um
flip? Did you like
gosh.
multiply by the reciprocal? Did you
No.
invert and multiply? No.
No. Uh,
What did you
ugh.
do?
So I know that 12/25 means 12 1/25. And so 12 1/25 divided by 4, then I'm really just thinking about the 12 things divided by 4, which is 3 of the things. So 3/25.
3 1/25. And so that's why your
Yeah.
answer was 3/25.
Yeah. Yep.
And that's interesting. You're saying that you can think about 12/25 as 12 1/25, 12 things.
Yes.
So therefore you can just think about those 12 things divided by, I'm just repeating what you said, sorry, but
Yeah.
12
Yeah. Well,
20.
I mean,
Yeah, go ahead.
I at the risk of taking a long time, that's a struggle, right? Like when kids are seeing the fraction 12/25, like, do they think that's 12 of 1/25? Like
Mm-hmm.
I think all throughout we've been talking about, we say 12/25, but we also say 12 1/25.
Mm-hmm.
Just to kind of like hint and nudge and remind that you're talking about 12 of the unit fraction.
Yeah, and y'all, if you've only ever thought about fractions in a part whole sense, which is the way the education system is set up, is to typically introduce fractions as 12 out of 25. And the only thing you
Uh-huh.
can picture is 25 things and 12 of them. And you're thinking about
Uh-huh.
counting those 12 things out of counting 25 things. We would really encourage a much more multiplicative view of 12/25, which is
Yeah.
12 of those 1/25. I've got
Yep.
this 1/25 and I got 12 of them. That's very much more multiplicative. And so if you can kind of set aside what the thing is and just think about, well, I got 12 of these things. So 12 of 12 whatever's divided by 4 is going to be 3 of those things. What were the things? Oh yeah, they were 1/25.
Yep.
All right, cool. Next problem. How about 16/25 divided by 4?
16 of the 1/25 divided by 4 would be 4 of the 1/25.
Because
So
16 anythings,
4
yeah,
25ths.
16 anythings divided by 4 is going to be 4 of those things, 4
Yep.
1/25.
Yep.
How about 14/25 divided by 4?
14/25 divided by 4 is smack dab in the middle of the 12/25 and the 16/25. So it's going to be smack down in the middle between 3/25 and 4/25, which were my answers before. So I'm going to go 3.5/25.
3.5/25. Hey, I'm curious how you wrote that, because I just wrote 3.5
I did too. I wrote 3.5
25ths.
division line 25ths,
Yeah, same here.
which
So
people will
if
not
you
be happy
had,
with.
well, they'll have to get over that.
Okay.
If you wanted to write that as an equivalent fraction that didn't have a decimal in the fraction, do you have a thought about that? What's 3/25
Yeah.
is equivalent to?
7/50.
And you divided, or you like 25ths you could are equivalent to 50ths, and so you're just like, oh, I can just think about, yeah, cool,
That would be, yeah.
7/50ths.
Uh-huh.
Nice, cool. Next problem. How about 13/25 divided by 4?
25 divided by 4. So I could take the 12/25 that I had before divided by 4,
Mm-hmm. Mm-hmm.
and then that's what I would have left is one more 25th divided by 4. Or I could see that it's nestled between the 12/25 and the 14/25.
Mm-hmm.
But either case, I'm going to say it's 3.25 25ths, 3.25 25ths.
Nice. And if you had to find an equivalent fraction,
That would be 13 hundredths.
Why'd you say 12?
Because I thought about 6.5 50ths, and I forgot about the half. I thought about it again.
Oh, I thought you were talking out loud.
Yeah, but you know what?
12,
Like,
then 13.
Here's the thing, though. I absolutely, when I wrote 13 hundredths, I smacked myself on the head, like literally went, ugh. Because 13 25ths divided by 4, I could have said I have 13 1/25ths, but I want to think about, instead of 1/25ths, I'm going to divide that by 4 and go 1/100th, but I still have the 13 of them. Does that make any
I
sense?
think you're going to have to say that again for many listeners.
So when I landed on 1300ths, I looked over at the
As the
initial
answer.
problem. Yes, as the answer. I looked at the initial problem and I went, ugh, Kim, 13. Instead of thinking about it like 13 divided by 4, but stay in 1/25th land, I could have said, I still have 13, but mess with the 1/25ths divided by 4, which is 100th. So I was focused on dividing how many of the things that I had, but I also could have thought about scaling the denominator, like thinking about the 25ths divided by 4. In other words, I could have scaled down either how many I had or the size of the pieces.
Yeah, nice. And another way of saying that is you could mess with the numerator or you could mess with the denominator.
Yeah.
And if I could point out every one of the problems, so when you did 12 25ths divided by 4, which was brilliant, you thought, well, I can do 12 anythings divided by 4. I can think about that. You were messing with the numerator. And so you're like, well, 12 divided by 4 is 3. Well, what were the things? Oh, they were 25ths, 3 25ths. But what if you'd scaled the denominator? What if you thought about 12 25ths divided by 4 and ignored the 12 for a hot minute and said, what are 25ths divided by 4? What 25ths divided by 4 are? Go ahead.
Hundredths. And so I would have had 12 of those hundredths. So it'd be 1200.
12 hundredths. Yeah. And you had gotten 3/25. You had gotten 3/25ths. Is 3/25ths equivalent to 12 hundredths?
Yeah. Yeah.
Show enough. Yeah. Nice. And we could go back and do that with each one of them, right? So we want to build that facility in students to be able to think sort of about these problems both ways. Which one makes more sense in the moment? And when you got down to the 13/25ths, on purpose, I kind of gave you a problem where you're like, ugh, do I really want to think about 13 divided by 4? I mean, I can, and it's in between. And that was, we had some other problems for you to mess with to do it. But then when you saw the answer as 1300ths, that's a ping to go, oh man, this whole time I could have been thinking about denominators as well. Super. Y'all, it's not about one and only one way to do something. It's about dense relationships. And how do we build those dense relationships? It's experiences. Every day that you don't give experiences like these problem strings is a day where students will flounder with fractions. So, y'all, 3 important things. The definition of fractions. We want to have kids always go back to, can I think about this problem based on what I know, how to name the piece? If I think about these pieces, can I reason and then name the piece? So first, the definition of fraction. Second, use context. You might have noticed that the candy bar was super helpful. Use context as much as you can. And third, teachers, before you worry about getting to cranky stuff where it's fractions divided by fractions and all these cranky numbers, instead work with fractions divided by whole numbers and whole numbers divided by fractions. That was in our other episodes we told you about earlier. Work with those first, even though they're not part of your standards, because you're going to get at your standards to help students reason about fractions from the get-go.
Yeah. And I'm going to go back to the idea that kids can't intuit that. If we these experiences, if they have a good sense of division and a good sense of fractions because we've given them those experiences, they absolutely can intuit it.
Absolutely. Y'all, thanks for tuning in and teaching more and more real math. To find out more about the Math is Figure Out, you know what? I am going to, hang on. Kim, I wanted to say one quick thing, and I forgot about it just now, in the middle of that ending. I got to tell you, after I had this Twitter conversation, I was at church and I grabbed a bunch of kids. I had a kid that was, I think I had a 9-year-old up to a 14-year-old, and there's about 5 or 6 of them. And I said, y'all, can you think about 1/25th divided by 4? And they kind of looked at me and I said, like, do you know something like, and I did basically a brief kind of, do you know 1/2 divided by 4? I did like 2 easier problems with them. And at first they said they said 1/25th divided by 4 was 1/75th. And I said, why? With that good neutral response. And very quickly, in fact, the youngest kid was the one that went, no, it's 100th. 1/25th divided by 4 is 100th. And all the rest of them were like, oh yeah. And then we had this great conversation. Y'all, kids, can they reason through it? Yes. Do they know it right away? Maybe not, but can they reason through it? Absolutely. All right, y'all. Thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figure outable. Thank you for listening and making math more figure outable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figure outable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.